Hello, everyone, and thank you for attending today's webinar. I am Deborah Walston, and I will be today's webinar moderator. Before we begin, I'd like to review some housekeeping items. The audio is muted, except for our presenter. If you have questions or comments, please use the Q&A feature to submit them. We'll address your questions at the end of the presentation. To open the Q&A feature, scroll your mouse to the bottom of your screen and click on the Q&A item. We are recording today's webinar and will post a presentation and recorded webinar in the SPE library. You also receive an email with a link. We are thrilled to have Lenny Gutierrez here today to discuss how to implement a purge program and stop wasting money. Lenny is a technical service representative with 20 years of purging expertise with Asaclean purging compounds. He launched Asaclean's international expansion into Mexico and South America in 2009 and has led tremendous growth and increased brand awareness in the region. Lenny is one of Asaclean's most knowledgeable subject matter experts. Let's give a big welcome to Lenny Gutierrez.
Thank you very much. And let's begin. Let's see if we can get as much info packed in here, and let's be respectful of your time. Thank you so much for your time this morning. So, how to implement a purge program and stop wasting money. A little bit about our parent company, Asahi Kasei. They are a global conglomerate, and they have their hands in pretty much everything from materials to automotive, healthcare. They are in Japan, and they currently serve across all their companies and wholly owned subsidiaries. They serve over 100 countries. Sorry about that. And now about Asaclean. It's a leader in the commercial purge business worldwide. And what makes Asaclean special, what makes Asaclean unique, it's the engineering behind it. The engineering that goes into the creation of our mechanical and chemical grades, and now our concentrate grade, which has been launched this year. Typical benefits of using the right purge compound for your process would be reducing machine downtime so that you have it for what it's for, and that's making parts for your customers. Removal of color and carbon contamination, which is common with polymers, that they degrade and become carbonized, makes it more difficult to remove. But also, when there isn't contamination present, you can just have a color change, black to white. Reds and blues are pains in the butt as well. Material changes, particularly ones that span across wide temperature ranges. We can be helpful there as well. We also have hot runner capable purge compounds, some of which are even moldable, but obviously we would review your molds details, or you could review them with your assigned Asaclean technical rep, and we'll make sure we get you the right product, because running anything through your molds, we want to make sure you feel confident and secure, and that you could trust the product. Increased output, obviously, with reduced machine downtime, and lowering those said costs. Faster and easier screw pulls, because pulling a screw could be the most difficult event that takes place in a plant. Sometimes just the sheer effort that it takes to pull the screw is enough to write a tale about, from tying up chains and belts to forklifts. And not sure if any of you had that experience, but it's a sight to see, and very difficult and dangerous. And also shutdown and sealing. We'll get into that a little bit deeper later on in here, but it's trying to focus on identifying when contamination occurs, and it's typically occurs during downtimes, unexpected and planned downtimes, like a weekend or a holiday shutdown. So what we begin with when we want to move toward seeing if we have a recommendation for you, we want to understand your process. So some of the basic things that we all need to have crystal clear Or what are your applications? Or is it color changes, material changes? Is it screw and barrel only? Would you like to purge through the hot runners? Do you need to remove carbon specks from a clear application? Machine count and size, so that we can appreciate, what quantity of purge you might be expected to use, depending on the machine size and the nature of the application. And also, the type of purge compound will also determine the purge quantity. What production and quality issues are you seeing? Which customers care most about the aesthetic of their parts? What's important to your customers is going to be important to your purge program, so that we can deliver on time, or so that you can deliver on time parts, and that they're up to spec with no defects. What type of products do you use? I'm sorry. Do you make? So that we understand also what the aesthetic quality is, or the part integrity. Sometimes an all black part still needs to be confirmed free of contamination, because if there's any carbon in the part, it could affect the product's function. And temperatures and resins, of course, so that we can make sure we recommend the right grade. Typically, we recommend, specifically for our mechanical grades, we recommend you purge at the production temperature of the resin, as an FYI. How many shifts? How long are they? 25, 24/7 or 24/5? And what do your downtimes look like? Again, we're going to want to focus on when the machine is stopped, for how long, and what temperatures are they sitting at. How often are you pulling screws? How often is there maintenance scheduled for your molds and screw and barrels? Also, we'd like to know, what do you do right before a shutdown? Do you run the machine empty, or do you seal with some kind of resin or a purge compound? And then critically, how are the startups after these shutdowns? It's a very common occurrence, is to find contamination is right after a shutdown, is the startup after a prolonged shutdown. So we'd all like to see, when moving and considering to a new purge program, we want to know where you're at currently. I think you want to know where you're at currently. You want to establish the baseline. You want to know what costs are you're looking at as far as in downtime and in scrap. Are these quantities being measured? Is scrap being measured scientifically, or is it just kind of, it's a few pounds here and there? So some internal costing would be really important when you are gathering this data, so that we can have both measurements and the corresponding costs. So when you report that, okay, this particular color change yields 40 pounds of scrap, what does that scrap cost the company per pound or per kilo? And also machine time. If you guys are down 2.5 hours because of carbon specs or some kind of a product defect due to a lack of cleaning, is there a machine rate for that machine? An hourly machine rate for that particular press, so that we can say, all right, we lost 2.5 hours, based on the product that we're making here and how much we sell it for. This is how much we lost. So there's several ways to get to that hourly cost for your running machine. Sometimes it's part opportunity cost, like how much you would have made had you made these parts for your customers. And sometimes it's just man hours, energy costs, material costs. But knowing what these are very important when we're looking to improve upon these very numbers. It's what you're currently doing now, and what a product like Asaclean can, what kind of savings it can help you get. So understand your current results before you even start considering a purge program, so that we know, so it could be clear when there's an improvement. Peter Drucker, the famous businessman, you can't manage what you don't measure. Couldn't agree more. Okay, so for grade selection, we'll understand what your process is. We have grades for all thermoplastic processes: injection molding, extrusion, blow molding, compounding, blown film, even recycling extruders. And we'd like to understand, what are your expectations, or what are your previous experiences with Purge compound? Maybe there's some gorillas in the room we need to address, or some fears we need to assuage a little bit with some direct addressing of your past experiences. We have products, we have enough products in our line so that if your issue with a prior purge was too much residue, then we can be sure that what we recommend has a particularly low residue characteristic before a certain resin, like acrylic or polycarbonate. And what are your current pain points? Obviously, Purge is part of a problem-solving solution. So the problem usually is the pain to the company, which is lost machine time or too much scrap here. And especially this day and age with resin shortages and sourcing issues, we want to understand what's urgent to you. And then we choose a compatible purge. So a little chart here just to sort of show the spread of products that we have. We have on our left here, we have our mechanical grades, our legacy grades. These are the original Asaclean products, and they are very effective in scrubbing your machine safely. Then you have your chemical grades on the right, lower right. Chemical grades, we'll get into these a little bit more, and they have the ability to expand with their chemical reaction, which can help us address low flow and low pressure areas, for example, like in a sheet extruder or in a blown film die, or certain hot runner systems that have 90-degree angles everywhere, or the design just lends to more than one low flow area and hang up spot, if you will. And then we have our concentrate grades, which are working wonders as far as resin compatibility, smaller footprint. You're able to control the ratio, so when you need more cleaning, you can actually modify the mix. So a few different ways we can go here, and I'd say it's a good problem to have, where options, lots of options, good problem to have. That would basically help us deliver a more refined grade recommendation. So mechanical purge compounds, simply put, they scrub and clean strictly on the path that they travel on. So a mechanical purge does depend on pressure and agitation that we hopefully can obtain from the machine. Injection molding is therefore just a perfect marriage of a process for mechanical purge compounds, because we have the luxury of a reciprocating screw. We have the luxury of controlling screw position, back pressure, and everything else, rotation speed, injection speed. So with the right procedure, excuse me, let me dial that back. Asaclean is a good product, but when used with the right procedure, it can reach levels of just pure excellence. And so we ask you as a favor, and then also thank you ahead of time, please follow our instructions so that you can be sure you're evaluating the cleaning performance as accurately as you can, and so you know what you have on your hands. It has a very safe additives, nothing that's going to be considered abrasive, that's going to damage the screw surface or the barrel walls or the hot runner systems, so long as we recommend the right grade. And there's no chemical reaction, so there's no need to raise temperatures. There's no soak time, so there's no need to wait around for the purge to do its thing. And so a machine expert is going to really use a mechanical purge as their own tool, and let them and they'll know how to guide the machine to do all the work. Chemical purge compounds, on the other hand, while they do have carrier resins, And in some cases, you know, a relatively stiff carrier resin where you will get some mechanical push. The majority of the cleaning performance accomplished by chemical purges are through its chemical reaction. It's an endothermic chemical reaction. The only byproducts are water vapor and CO2, so no need to run for the hills. There's no toxic byproduct to the chemical reaction. And it helps, like I mentioned before, it helps address cleaning in tough to clean areas, extrusion blow molding heads, extrusion dies, hot runner systems, or even a injection screw and barrel that might have some wear or some, you know, some cracks and crevices, some valleys in there that we need to get into that a mechanical purge might otherwise have just, you know, walked right over, walked right on past. So a chemical grade is important for those types of applications and trouble areas. Soak times are you know, around 5, 10, 15 minutes, 20 and 30 on a rare occasion, but depending on what temperature we're at, that will dictate how long the chemical reaction will go on for. Earlier this year, we launched Asaclean Plus, our first ever purging concentrate. The purging concentrate technology is derived directly from our chemical grades, and it's a way to supercharge your processing resin. You will only be receiving the active ingredients, and you can adjust the ratio depending on what cleaning is required, which does allow for some pretty amazing results when it comes to on-the-fly purging. So even though it is a concentrate, meaning that it's like our chemical grades where there is some soak time and some temperature, possible temperature adjustment. Even though that's the case, you know, it's possible that we can run this without requiring process temperature changes. So it's a pretty bright future for concentrates to have their place alongside chemical grades and mechanical grades. Some tips in injection molding, you know, would be, for example, to improve the cleaning in the nozzle body area, the check ring area, which is really where the majority of hang-up can occur as far as the screw and barrel is concerned. You know, increasing the temperature, for example, in that nozzle body about 50 to 100 degrees, that can solve an issue that might otherwise be a nozzle body teardown that takes 4 hours. So be careful with resins that are likely to hang up in nozzle bodies, like Santoprene, for example, is a real pain in the neck. But sometimes it's simply just a nozzle body issue, or a nozzle body design issue. We also have purges that are moldable. So for hot runner purging, we do have a closed mold method that takes advantage of the pressures of the system, and that will lead to less purge quantity used. And it's another way of taking advantage of the pressures that the systems that the machine provides for us to help a mechanical grade that's moldable do its thing. So for extrusion, you know, for many years we still do have mechanical grade success in extrusion, but some hardware in the extrusion process does benefit from chemical grades, like die heads, downstream equipment, breaker plates, gear pumps. So and particularly the screw and barrel also. There's a low pressure concern just in general, right? Extrusion is a lower pressure process than injection. So so that does take away a mechanical grade's ability in some cases to perform as well as a chemical grade. So here, this is an instance where we have the crossing of two different possible solutions. Both, like I said, both mechanical and chemical have their respective high probability of success for this process. So twin screw applications also no problem. Obviously, we just be careful with the star feeding as opposed to flood feeding. Make sure that we're keeping an eye on torques and pressure plugs. And then, of course, the areas adjacent to vents, a vented barrel. That those zones near the vents will because it's lower pressure. You could have some issue getting some mechanical scrubbing there as well. We'll ask you if you can plug those vents, because if there's a chemical purge compound being used, we'd like for you to help contain the gases as they're created, the chemical reaction. And so we're able to address those, or at least take those areas into consideration when making our final recommendations, both on product and procedure. All right, the cost factors. Let's get into it. Cost per purge versus cost per pound. So clear difference here. Cost per purge includes the time that it takes converted by your machine hourly rate, and includes the amount of resin that was used to displace the purge out of the machine, and also the amount of resin total in your scrap on your next run, which we presume all these measurables should improve when compared to a better purge option. You'll have less lost machine downtime. Less lost machine time, less scrap, all of which should help reduce that total purge cost, which is really the cost that we should be looking at. Cost per purge. Cost per pound is really only one of 6 factors when looking at a cost savings analysis. So, giving a cost per pound any more priority than 1/6 of a solution, it's a risky thing to do. So we look to be consistent in the data collect. Make sure that what's measured and what matters with your current purge program, that those same measurables and that same data be collected with whatever new purge method or purge product you're looking to consider. In the end, comparing 2 purge methods should be very easy as far as seeing which one is best for your company, because 99% of the time it's the one that costs you the less, or the one that solves your problem, the one that makes your customer happy. So keeping track of these over time is critical. If we want to see where the results are, what effect a purge has on these particular measurables, time, scrap rate, reject rate, overall, and knowing the corresponding cost factors, it'll help you get to a cost savings analysis real quick. And that's the best place to be as far as comparing 2 purge methods. So why use a purge? Well, it improves safety. If you can see the look on some of these maintenance guys' faces after we save them from having to pull a screw, they can spend their time on other tasks, far less dangerous tasks. Obviously, increasing machine capacity. If you're having trouble filling orders for 10 customers, well, then you can't consider being a 15 customer business or bringing in more business. So, freeing up machine time is a big one for purge compound. You lower your maintenance costs, obviously, because the expectation should be that a higher performing purge compound it'll send your screw off to maintenance far fewer times a year, or maybe never in best case scenarios. So it's common for customers who, before implementing an efficient purge program, they were pulling a screw every month, every couple months, maybe after successfully implementing a program, now it's every 18 months, or they can't remember the last time they pulled a screw. So it's just a question of efficiency. It's going to improve the usage of your resources, from energy to manpower to resin to machine, and that first pass yield is always nice to see on the production floor. Where it's just As soon as you get started, well, that's when you're really getting started, and it's not beginning with a few hours of contamination or prior color showing up in the part. And of course, lower scrap, more efficient machine usage. Of course, this is good for the environment, and it's an excellent example of reducing plastic waste. So instead of producing, silos of scrap, you're looking at just a few piles here and there. So this is a kind of stating the obvious, but please follow the instructions to the letter. Basically, it's just a question of making sure it's communicated that, look, we're not. It's not a lack of trust of the process engineer. We're not saying you don't know how to purge a machine. We just like you to use this particular product's specific recommendations because it's going to work better for you. You're going to use less. It'll clean better. And also, you're going to use less of your own resin to get the purge out. So following our instructions for both purging and displacement, that's going to get you to the promised land. And then from then on, after you consider what we recommend, you're certainly free to try out something if you think it's going to lead to better efficiency. And it has happened. Together, we will help you determine the grade and the type of purge compound best for your needs. And we'll make sure to be there as far as giving you those important tips on the temperature profile of your system to get the best possible cleaning as well. In-house purge compounds are very common, but we should always look at their possible deficiencies. Are they resistant to oxidation? Are they thermally stable? Can they withstand being used as a shutdown sealant? Are you creating possible layering inside of the machine? How are your startups? What do they look like? Are you seeing contamination from the resin that was run last week? And also, obviously, consider the viscosity of the in-house purge. Is it easy to remove with your next material? So on and so forth. Just different possible pitfalls for in-house purge compounds, resins, and regrinds. Changeovers. So according to the science of fluid dynamics, normal polymer behavior is going to be, as you can see here, a laminar flow, where it's going to want to really, the higher rate of speed is right down the middle. And as you can see towards the channel walls here, you see the red and the green. These are examples of layering. So it's very normal and very common for polymers to do this. And this is well, we're thankful for this because this gives us a lot of work. Accumulation of layers on the barrel wall and also on the screw flights. It's tough because once they are on there as a layer, then the clock starts as far as thermal stability goes. And those layers almost certainly always become degraded, or they will just sit there and then maybe show up gosh knows when. And it's just not stuff you want to have in there. It's going to reduce your output as well. I mean, if you're talking about layers over time on the screw flights, you're not going to be able to carry the same amount of material in that barrel or in the screw. Going on to an example of a color change in injection molding here, we have the use of just white propylene. It took 1 hour and 3/4. It took 350 pounds for a total of 871. But when you used Asaclean, that 1 hour, 45 minutes turned into a half hour, 350 turned to 80. There was 20 pounds also there used of resin to help displace the purge efficiently, because the purge event's not over until the purge itself is out of the machine. One very common mistake made is as soon as the purge comes out clean, engineer gets excited, said, all right, let's go back to production, see what it looks like here. But so it's very common to forget that step. So let's just dedicate one more stage of good procedure to help get the purge out of the machine. Anyway, so it's only 20 pounds were used here, and that's one heck of an improvement on the spending here. 871 to 496. So if this happened five times a week and only 48 weeks a year, you're looking at 90K over the course of a year on just that application. %73 savings. Here's an example, recent one actually, of a trial with our concentrate. And as you can see here, the amount of material is just drastic here. You do have to include here the 625 pounds of resin that was used alongside with the purge concentrate, as it is something that you mixed. The purge concentrate has to be mixed with your resin or with a resin that can be provided. But as you can see, every measurable here, the time to the total amount of material used, no surprise that you get the savings that you get here. Here's a comment from a happy customer. So easy and works incredibly well. Those are nice nice to have in a product. The projected annual savings here, pretty heavy at 50%. So preventative purging, just to be clear, there's reactive purging and preventative purging. So the reactive purging is, you want to count on having a big enough gun or a strong enough purge, because you know that when you purge, you're reacting to contamination already present in the machine. But then there's preventative, where in most cases, this is going to net you a lower total spend on purge. And that is purging before the contamination occurs. So one very common question is, well, how often do I do that? That's going to really depend on your scrap rate, and it's going to depend on your resins. We've seen programs where people purge every day or every weekend or once a month. Some programs can, or actually I should say some resins can be afforded to purge every couple of months, because they're really just they're pretty noble, they're pretty stable. So really it's just we do need to take a closer look. We can't give a blanket statement as to how often you should purge preventively, but taking a look at your scrap charts, identifying when your shutdowns are, AKA the opportunities to purge, or the opportunities for your resin to degrade, that's going to help us sort of paint your picture as far as when you should be purging. And it's important because you are purging the polymer at its easiest state, in their beginning state. Once that polymer begins to degrade, or once carbonization gets involved, you're looking at a tougher purge application that's going to require either more purge or a stronger grade. So if it's avoidable, why not? On this chart here, everything left to the vertical black line where it says revised purging procedure using Asaclean started. As you can see, after every startup, there is a period of lower scrap, but it doesn't really last long, and you have a defect percentage that is in flux. It's constantly coming back up. You install a new screw, okay, you lower scrap temporarily, but here goes the scrap again. When you use an effective purge program that successfully removes layers and actually removes the polymer, then you're going to be looking at these consistent lower scrap rates, as you can see to the right of the line. pretty drastic improvement there, 18 to 0.05, 7.2 to 0.59 at this automotive injection plant. Shutdown and sealing is, well, that's the most popular preventative program, and it's specifically, or I'm sorry, it's basically purging before a shutdown, and instead of displacing the purge out of the machine, you're leaving the machine filled with the purge, keeping out the oxygen, which is the catalyst for degradation, but also some of our grades, when they're left in the machine, they shrink and they contract, and they'll pull away from barrel and screw surface area, sort of giving an added cleaning there. But for the most part, it's really just a matter of effectively cleaning and then sealing your machine so that your startups don't have an hour or two or more of fighting off carbon. So, do we recommend you seal every machine every time? No, we'd like you to start with the ones that give you those headaches during startups, the more heat sensitive materials. It is an often overlooked function of a purge compound, but some grades are versatile in that they can be used for sealing, for hot runners, and for material changes and color changes, and could even do a decent job on carbon. So it's a good thing to have certain grades that are that versatile, and that way you're not going to be using 2, 3, 4 purge compounds. We can try to keep that grade selection to a minimum. Just some visuals here on what a natural ABS looks like after 15, 30, 60 minutes. Big change. And comparing it to some of our grades at those same temperatures, just to show that we are very conscious of the thermal stability of the ingredients and the resins that we choose to create our purges with. And we can provide some data to help you feel more comfortable as far as the thermal stability, residence times, things like that. So shutting down and sealing really is just going to help prevent the screw images on the left. And on the right, you can see, on the bottom right, you can see the best case scenario of what a well maintained, well cleaned screw can look like with purge compound. Excuse me. Screw pulls. Not sure if we have any maintenance guys here today, but this is one of the more popular uses of Asaclean. We have a grade called the EX that's just, it's the strongest cleaner we have, and it's going to give you 3 benefits for those guys in maintenance. One, probably the most important to some of these guys, the physical force required to pull the screw out of the machine. After you purge a machine with the EX, you should have a far easier time pulling that screw out of the barrel. The EX, as you can actually see in this picture, and I'm going to show you a video shortly, it actually wraps around the screw like a ribbon. It's actually easily removed from the screw with just a glove even. It's almost like an orange peel. So it does contract and sort of binds together, which makes it a very unmessy ordeal. And then the third benefit, of course, obviously, is once you remove that peel from the screw, you're going to find a screw in a far better state, where maybe previously it took you a couple hours and a few guys, with wire brushes and blow torches, or throwing a screw in the oven, for a few hours or a couple hours. It turns it into maybe just a few minutes, wiping a little bit here and there off, and you're good to go. Slap that screw right back in there. So that would minimize manual cleaning, which can be a bear. And aside from you lucky folks who have backup screws, this would decrease your overall changeover time if you're not waiting on a screw. I'm sorry, if you're waiting on a screw to be serviced and maintenance. Here's the video. Now, obviously, we understand this extruder that you're seeing here. It is a lab extruder, so this is really for visual purposes only. And what we're trying to visually illustrate here is the ease of pulling the screw out. As you can see here, when running black ABS, the guy's using some force there. Now, this is a lab extruder. I promise you that in a real life production injection or extrusion machine, that pulling of the screw is far more difficult. But then with Asaclean, with the EX grade, you'll see, first off, you'll see the difference in the consistency of the material. The ABS was far more gummy and far more of a difficult to remove. Meanwhile, the Asaclean stiffens up pretty quick and turns into almost like a potato peel or orange peel, and it comes off real easy. And then hopefully you won't have much cleaning or scrubbing or blowtorching left to do. All right, how do I move on from here? Okay. So, like we said, we find it very helpful when all the measurables are accompanied with the corresponding costs. So let's do it again here for a screw pull. Screw pull might have cost 12 hours of machine time, and that machine running that particular product, that particular machine size running that particular product for your customer, maybe it's 85 an hour. So we have to look at that time as having that cost, carrying that cost. And as you can see, we're looking at some pretty big savings. So instead of 12 hours, it's just going to be a few minutes. And in some cases, in the best cases, we do save you from pulling the screw. Save the instances, of course, where you're obligated to pull the screw because of, that's what you promised the customer. But even those, we can help you because of, we want you to use the least amount of time and effort to pull the screw, to clean the screw, and to get it back in. But it's also just makes for a safer workplace. And at one screw pulled a month, you're looking at some good savings as well. It's always nice to annualize your savings to see the real effect over the course of time. So just a few added notes here on our services. Asahi Kasei as a whole, we offer incredibly advanced R&D and product development, and so we want you to see us as a trusted supplier that is, firstly, a quality supplier, and we've been very fortunate with our sourcing and with our material sourcing. So no concerns on providing you with product. Knock on wood. And we have our team. Most of the guys on our sales team actually have on the floor experience. So combined, we're talking about a ton, really a ton of plastic processing expertise. So it's not just purge knowledge. We have some plastics industry and plastics processing knowledge as well to help us help you. And we are customer facing. We like to be at the trials. We like to visit our customers, and we also have several warehouses, so we can help keep your shipping costs down. We always ship from the nearest warehouse. So a few different ways we can try to be a stellar supplier for you, so service is extremely important to us, not just quality product. If you'd like to learn more, please visit our website, asaclean.com. I want to thank Tom Hanvey, our marketing manager, for doing just a bang up job on putting a ton of information. But please defer, or please set up a call with a technical service representative to help you with your grade recommendations. As the information on the website is general on purpose, but we want to make sure we understand your Purge program more specifically, and that way we can give you a more customized recommendation. And I think that'll do it. Thank you so much for your time.
Thank you, Lenny. Let's take some questions from the Q&A window. The first question, what was the name of the grade that was used in the screen pull video? That screw pull video.
That was the EX grade, the letter E, the letter X grade, EX grade Asaclean.
Okay, next question. Are purging compounds safe for hot runners?
Yes, and that's a legit question. You know, the hot runners, you know, your tools, the tooling, those are like the babies of the plant. You know, they require the most care, usually the most expensive. But yes, we have grades that are proven safe through hot runner systems. Obviously, we want to qualify each mold. So although it is a blanket statement that we do have hot runner safe grades, we don't want it to forego a qualifying conversation, a review of your mold characteristics. You know, just simply minimum gate clearance. You know, what are the minimum tolerances? What are the how many cavities? You know, what type of internal heating are we looking at? But yes, we have several grades that are safe for hot runners.
Next question, post-purge, can I run a medical plastic mold?
For a medical plastic mold, so it depends what kind of red tape we're looking at here. If you've promised your medical customer that you guarantee no contamination, then officially we have to say, you know, the only way to know for sure that a machine is contamination free is by pulling the screw. So it depends. We have many medical customers. So I think what we can tell you is that we have materials that can both do the cleaning you need and that can get out of your machine the way you need, because obviously some of these parts cannot tolerate any contamination of any foreign or previous resin or purge. But we can't free you of your responsibility to your customer and say, oh, we guarantee it's going to be free. But we have many satisfied customers that successfully use the purge without any contamination issues from the purge compound.
Okay.
I hope that answers the question.
Next question. Do you have any options for people in blown film extrusion?
Yes, very much so. Our chemical grades and our concentrate grade do a really good job on both removing carbon contamination from the blown film die, which is typically the issue, but also to help accelerate color changes. We even have a couple of grades that can hold the bubble. So for those of you that want to purge on the fly without breaking the bubble, we have a couple of options there as well. But we understand it's really just those two applications for blown film that take up the majority of the possible applications. It's carbon in the die or color changes and keeping a bubble.
Okay, next question. Is someone available to help me build my own purging program, and is that free?
Yes. There is no additional charge for visiting your plant. There's no additional charge for reviewing or helping you administer and write up the purge program. No, there is no charge for that. That is part of our service, and it comes with the product. We could say that.
Next, what are the best applications for the concentrate grade?
The best applications for the concentrate grade, There's a few applications where you need a good amount of cleaning power, but there's an issue with resin compatibility. That's one thing that Purge Concentrate solves, is that mixing it with your own resin, there's rarely ever the case where you're having an issue with Purge residue. Also, the Purge Concentrate is just fantastic for low pressure applications, hot runner cleaning, blown film dyes, extrusion blow molding, are some of the maybe not slam dunk, but I mean, we're talking excellent performance when it's done with the right procedure. Actually, yeah, when it's done with the right procedure, it is a slam dunk. But no, it could be, maybe a purge program that is looking to reduce the overall footprint, or the overall footprint of material in the plant, but also if you're just looking at reducing the amount of resin reducing the amount of purge compound volume that you purchase. So those are a few examples of where the concentrate can be attractive.
Okay, very good. I think we've come to the end of our questions. Thank you, Lenny, for an enlightening presentation. Do you have any final comments you'd like to make?
No, and just want to encourage anyone with any questions to please feel free to reach out to us. The smaller the question, the better. We want to avoid misunderstanding during your consideration of Asaclean or of Purge compound. So yeah, please feel free to use us as a knowledge center as well.
Very good. We'll be posting the presentation and recording in the SB library. You also receive an email with a link. Please be sure to check out our upcoming webinars and have a great day.
Thank you, everyone.